In part A, we have 3 radical 5 times 2 radical 7. And we want to figure out, well, how do we multiply these guys? And again, I'm not talking about turning them into decimals and then multiplying. You can do that all day long on the calculator and get an approximation, and you should be able to do that. But what I'm talking about is getting an exact answer. So we're not going to lose the square root symbol. Okay, if it's an applied problem, we might want to get a decimal approximation. But here we're going to get the exact answer. So how is it done? So we're taking the radical expression 3 radical 5 in parentheses times the radical expression 2 rad 7. Well, you can just drop the parentheses. You don't need them for anything. They're not doing anything. And you could rewrite this as 3 radical, it's really 3 times radical 5, right? That operation between the 3 and the 5 is multiplication. And then times 2 radical 7. Now, I'm going to show you a step you don't need to show in the future, but I want you to understand why it works the way it does. You can switch the order of the multiplication around. So you'll get the same answer if you switch the 2 and the 5 around, the root 5 rather. So again, I wouldn't necessarily write the step down, but in the middle here, I'll do it in green, instead of root 5 times 2 in the middle, you could have 2 times root 5. And then on the ends, I didn't change the ends, so I'll do those in blue. So 3 and then radical 7 on the ends. That's called the commutative property of multiplication, the fact that you can switch multiplications around. Okay, so now wait, can't we just multiply from left to right now? What's 3 times 2? Okay, you get 6. And then we know how to multiply radicals together. What's radical 5 times radical 7? Combine it into one big radical. What do you get? Radical 5 times 7, which is radical 35. So you get, you don't need to show the operation, 6 radical 35 as your answer. Now, are you going to do all that work in the future? You're going to go right to the answer. You're going to remember, oh, I'm going to multiply the guys underneath the radical together, make one big radical. I'm going to multiply the guys outside the radical together. And it's all one product. It's not, there's no distribution involved because there's no plus or minus sign involved, right? Okay, so that's how you remember it. Multiply guys outside the radicals together, multiply the radicands together underneath one big radical. In order for this to work, the indices have to be the same. They both have to be square roots, or they both have to be cubed roots, or they both have to be fourth roots when you do the multiplication.
You're saying the index of each.
Yeah, so you can't have like a square root and a cubed root and do it this way. It's not going to work. In the second problem, we have 4 times the cubed root of 5. That whole thing multiplied times the quantity 2 cubed root 25 minus 2. Now, in that second quantity, there's a minus, right? So what law are we going to have to use? Okay, so I'm going to show you all the work here. You don't necessarily need to show all this once you get comfortable with the multiplication, but I'm going to show everything. I'm not going to simplify. I'm going to show the distribution, and then I'm going to show how to simplify individual terms. So I'll show what I'm distributing in red. So I'm distributing 4 cubed root 5. So that means I'm going to distribute it to this term and to this term over a minus sign. So minus. And so that's what I'm distributing. And then I'm going to leave those terms on the inside. I'm going to leave those as blue. So I need a little bit more room. Okay, so I'm distributing the 4 cubed root of 5 times this guy. I'm going to write that guy in blue. So times 2 cubed root 25. I'm distributing over a minus. So I'm going to multiply 4 cubed root 5 times that 2. Okay, does that make sense to you? It's distribution, right? It's not new, is it, so far? It's the distribution property over subtraction. And then it's like we have 2 of those above problems in one. So just work on the left-hand one. What do? We have the same indices, so we're good to go. We multiply the guys on the outside together. What do we get? 4 times 2, 8. And then one big cubed root. It is 5 times 25. You may recognize that as 5 cubed. Or you could write it as 125 and then you'll realize later on, oh, that's a perfect cube. Okay, we'll simplify that further in the next step, but then the other term, we just have a 2 on the outside, so how do you think we handle it? And then the 4 here, how do you think we handle that? Just 8 cubed root 5. There's the minus is right here. We're distributing over subtraction, right? So the minus you can keep out in front if you want. So that's 8 cubed root of 5. Now we're not done. We need to simplify a little bit, but does that make sense? Okay, what's the cubed root of 125? It's cubed root of 5 cubed. It's 5. So it's 8 times 5 in front minus 8 times the cubed root of 5. That guy doesn't change, right? Cubed root of 5 is simplified all the way. So what's the final answer? Just 40 for your first term minus 8 cubed root 5 for the second? Everybody agree with that? Is there a way to check your answer on these numerical ones? You bet. Just in your calculator, type in the equivalent of the given problem, and then type in 40 minus 8 times cubed root of 5 and see if they're the same decimal. They better be, or you did something wrong.